All right, so what we're going to do here is we've got two sections that we combined into one. We're going to talk about a little bit about the metric system of measurement, which is something that even if you haven't been formally introduced to it, you have interacted with the metric system quite a bit. So the metric system is what is called a base 10 system for measuring physical quantities. So what I mean by base 10 is the number system that we use every day is base 10, right? So we have 10 fingers. Every time we count a full group of 10, we carry one over. So that's when we add and things like that. Every group of 10 moves to the next position. So if you're interested in place values and number systems, we talk a lot about that in MGF 1107. If anyone's going to be like a teacher in elementary school or middle school where you're going to have to teach some math, that is a great class to take. Gives you some background and things. Anyway, just a little plug. And so we are used to, in the United States, we are used to what was formerly the English system, but they don't use it anymore. We and one other country are the only ones that use what's now called the US system of measurement, where we have things like pounds and feet and miles, and that's what we're used to. But a benefit of the metric system, one of them, there's a bunch, but one of the benefits is that doing conversions is super simple. Converting in the US system, which we will probably begin to talk about a little bit today, and we'll finish up talking about it next time, is a little more difficult. So here we go. There are 3 base units that we are going to use in this class as far as the metric system goes. So the base unit for length is called the meter. This classroom doesn't have one, some of the others do, but if you're familiar with a yardstick, a meter is like 3 inches longer than a yard. Okay, so a yard, you might know, is 3 feet. I'm sure you've seen a teacher with a yardstick in a classroom before. A meter is 3 inches longer than that. The base unit for mass is called the gram. You're probably familiar with grams from the packaging on foods. Grams and some of the related units are used on foods to measure the amount of things in the food. And for volume, the base unit is called the liter. And we're familiar with liters because we probably like to drink soda, and we've seen the 2-liter bottles of Coke. So that contains 2 of this thing called the liter. So what we are going to do, again, we are just doing a real basic, quick overview of the metric system. We are just going to concern ourselves with the main, what you would use everyday basis. If you're going to some applications, like some nursing applications, if that's any of you, you might see some other prefixes other than these ones. It just depends on your situation. Okay, so the prefixes that we are going to use are these. The first one, the biggest one that we're going to have is kilo. Okay, that's the prefix that we can put in front of our base. So we can talk about a kilometer or a kilogram or a kiloliter. So what kilo means is it means times 1,000. So when you say that you have a kilogram of something, that means you have 1,000 grams. Okay, that's what this lingo is telling you. If you walk a kilometer, that means you've walked 1,000 meters. The symbol for kilo is just a K. All right, the next one is called hecto. That's the next prefix that you see in the metric system. Hecto means times 100. So again, if you have a hectogram of some substance, then you have 1,000 grams. Okay, that's how these prefixes work. That's what makes the conversion so nice and streamlined when you learn how to do it. And so the prefix, or excuse me, the symbol for hecto is an H. The third one is deca. Deca means times 10. And the abbreviation for deca is D and an A. And there's a reason that it's not just D, and you'll see that in just a minute. The bases, if you're talking about meters, the abbreviation is an M. If you're talking about grams, the abbreviation is a G. If you're talking about liters, the abbreviation is an L. So those are the prefixes for when you have multiples of something. So now if you're talking about parts, okay, then you have deci. What deci means is a tenth. So you have 1 part out of 10. So if you measure something and it's a decimeter, then that's 1/10 of a meter. Okay. The prefix, or excuse me, the abbreviation for deci is a little d. That's why deca is DA, deci is D. The next one's centi.
They have to be lowercase.
Yes, the metric units. That's not something I'll mark off on in here, but if you're out and about and you're using this, you would use lowercase for these things. Yes. So centi is 1 part out of 100, so 100th. So if you're reading the back of whatever food you like and you see that there's a centigram of sodium in it, that means that there is 100th of a gram. The abbreviation for centi is C. And then the last one that we will concern ourselves with in here is milli, and that is 1,000th. And so if you're drinking like a can of Pepsi or a can of Coke, whatever you prefer, a 12-ounce can is approximately equal to 355 milliliters. Okay, so 355 milliliters. So the letter for that is M. So what we're going to talk about here is we're just going to concern ourselves. Oh, by the way, there's an acronym or an acrostic. I forget what it is. So if you want to remember these, your job for the next test, okay, you're going to have to do these conversions. Your job for the next test is just to remember these prefixes. Once you remember the prefixes, you are good to go. And so I just got this online. I don't know if this works for you or doesn't work for you, but the most common little sentence to remember this is, I think I'm hearing you say it. King Henry. Maybe you heard a different one. I heard died by drinking chocolate milk. And what a way to go. Yeah, whatever words you want to put to it, you don't have to remember it that way. But if you have a different one, I also heard one about cats and dogs, but I don't remember it. It doesn't work as well for me. But if you just Google it, I'm sure other more creative people than me have made up other little sentences that you can remember in order to remember the prefixes. That's all that is a little tool. If you don't like it, great. If you do like it, fantastic. So here is how we are going to convert. The conversion goes like this. Example 1, we are going to convert 457.3 meters to kilometers. So once you remember the prefixes, since this is a base 10 system, it aligns very well with our numbers. What we're just going to do is we're going to see where am I going to move this decimal right here. So I'm just going to use my little chart right up here. I'm starting at meters. I'm going to kilometers. So here my pen is at meters. And how many hops and in which direction do I have to go to get to kilometers? 1, 2, 3 to the left. So I'm going to move the decimal here 1, 2, 3 places to the left. And so that becomes 0.4573 kilometers. That is the value of the metric system being base 10. It makes converting between different units super quick. So it's just a matter of getting used to the prefixes. So next one, I've got 142 grams. I want to convert that to centigrams. So here I am, my pen is at grams. Which way and how many am I going to get to centigrams? To right. Now, on this particular problem right here, there's not a decimal on the number. Where is the decimal? It's not in front, it's at the end, it's in the back. It's 142 point whatever, 0. So when you don't have any decimal, you don't have to write it. So I'm going to take the decimal here and I'm going to move it 2 places to the right, you said. So that's going to be 14,200 centigrams. Now, I'm sure you've had some teachers that might have given you different ways to do this, and that's great. There are other ways to do this, but this is the way that I'm going to show you because I think it's nice and quick and direct. Okay, so if on the test, if you have different ways to make this conversion, I'm fully comfortable and confident with that. That is great. So what I would like you to do, exercise 1, there's 5 problems right there. I'm just going to give you a minute or 2 to go ahead and do those conversions. If you have any question, raise your hand. Let's talk about it. Make your hops. I'm going to give you another 30 seconds. I'm not trying to stress you out, just letting you know. I'm just going to rewrite my prefixes here so I don't have to keep sliding the page and make everybody dizzy. So kilo, hecto, deca, my base, and then deci, centi, milli. So there we go. So there's my prefixes. So here goes. I'm going to convert 0.98 liters to milliliters. So liters is the base. So hopefully what you did is you moved your decimal 1, 2, 3 to the right. And so again, I'm just trying to give you a look of every possibility that you'll see. When I move my decimal 3 to the right, what do I have to add at the end of this number? A 0, yes, to accommodate that extra hop. So it's 980 milliliters. Anybody get something different that we have to talk about? Because the first 5 problems on the next test that you have are going to just be converting between the metric prefixes. So if you can do this, then you are good to go on the first 5 problems of the, no, actually the first 6 problems of the test. All right, the next one, we're converting 240 meters to kilometers. So once again, my meters is my base unit. I'm going to kilometers, so that means I'm going to do 1, 2, 3 to the left. So I move that decimal 1, 2, 3 to the left, and I get 0.240, or just 0.24. If you left the 0 off, that is technically mathematically better, but we're good. 1.25 hectometers, and I'm going to convert that to meters. So I'm going to take the hecto, I'm starting at hecto this time, and I'm moving to meters. So this time I'm moving 1, 2 to the right. So I'm going to move that decimal 1, 2 to the right and get 125 meters. We still doing okay? Because I swapped it up a little bit that time, and we started at the hecto and went back to the base. Okay, so if you can do that, then you've seen all the tricks. There's nothing else. Okay, 67.9 deciliters. So to liters, so deci right here, deci's right here. It's just 1 hop to the left. So I'm going to move that decimal there to 6.79 liters. And then last but not least, I got decagrams. I'm converting that to plain old grams. So deca is right here, and I'm just moving that 1 hop to the right. So I have to add 1 more decimal place, and I get 1,420 grams. Questions, comments, or concerns before I do my one other example, and then I've got a few more for you to do. Okay, so the last thing, what we've done, every problem so far has just involved the base unit. So my last problem here, my last example involves converting between two of the prefixes. So I have decaliters to kiloliters. It's the same process. I'm going to take my pen. I'm going to start at deca, which is right here. And I asked to convert it to kilos. So we're going to move it 2 hops to the left, 1, 2. So I just do the same thing I've been doing. I'm going to move my decimal place 2 hops to the left. So I'm going to take it here from the end of the number, 1, 2, 2 hops to the left to be 2.40 kiloliters. So the process is no different. You just have to notice which prefix you're going to and ending at. And my only thing that I will remind you of, this tends to be the only thing students kind of goof on when on the test, when you do your brain dump and you write down your prefixes real quick to do these problems, don't forget the base. Okay, sometimes students go right from deca to deci because those are the prefixes, but just don't forget that base in the middle. That's your units place. Okay. So next page, exercise 2. It's just 5 more problems just to practice. Is the left side what? I'm sorry? Is the left side of this? Is that what you're referring to? No, you would not convert from meters to liters because they're measuring different things. So it would all be meters, it would all be liters, it would all be grams, whatever particular thing you're measuring. So yeah, unless I did a typo here, all of the units should either be meters because meters is measuring length, and then grams is measuring mass or weight, and then liters is measuring the volume of something. So they're not doing the same thing. All right, so the first one is 33.5 centimeters to decameters. So centimeters is over here where the C is. I'm going to count the hops to deca. So that is 1, 2, don't forget the base, 3. It's 3 hops to the left. So I'm going to take this decimal place, 1, 2, 3 hops to the left. I need to add a 0 in front of the 3. So that's going to be 0.0335 decameters. Any other questions? Please feel free. We're almost done with section 7.1. It's just these metric conversions, okay? The next one's kilometers to decimeters. So kilometers is right here at the far left end of our prefixes that we're using. I'm going to count the hops to deci. So that's 1, 2, 3. Don't forget your base, 4. 4 hops to the right. So the decimal right now is at the end of the 4. So I'm going to go 4 hops to the right. So it's 1, 2, 3, 4. I got to add 4 zeros on there. So that's 14 with 4 zeros, decimeters. 550 milliliters. Now I'm converting that into deciliters. So milli is at the far right. So I'm converting that to deci. I'm going to go 1, 2 hops to the left. So that is 1, 2 hops to the left. So 5.5 or 5.50 deciliters. The fourth one is going from hecto to centi. So hecto is here in the middle between kilo and deca. So I'm going from here to centi. So 1, 2, don't forget your base. 3, 4 to the right. So that's 1, 2, 3, 4. I got to add a 0 on there. So that's 3450 centigrams. And then the last one is deci to milli. So if there's any questions about this basic skill that we're doing, please be sure to ask. Deci to milli. So I'm going to go 1, 2 to the right. So 1, 2 to the right, that's 50 milliliters. Yeah. So the question, in case you didn't hear, is what's the difference between DM and DL? Okay, so DM is a decimeter. So it would be about this long, is about how long a decimeter is. Okay, and a DL is a deciliter. And so it's measuring volume. So you'd measure like a liquid or something with liters as opposed to a length. And then grams is measuring mass or amount of substance. So like if you were measuring how much salt was in something, or how much of a certain drug. A lot of this we're doing because we get so many nursing students come through this class. So you've got to be familiar with the metric prefixes, because if you like to work on cars, all car stuff's metric, even cars made in the United States, because there's the worldwide standard. Medical stuff, any sort of construction stuff is all metric, pretty much. All right, so the last thing is just an exercise to practice this same skill. So what I've done here in exercise 3 is I've given you 3 measures. So 3.4 meters, 3,421 millimeters, and 104 centimeters. And what we want to do is we want to put these in order from the smallest to the largest. And the purpose of this is to help you get out of the habit of just saying, oh, hey, 3.4 is the smallest number, so that's going to be the smallest, then 104 is next, but they're all different units of measure. So what we need to do is we need to convert these to something in common. So here's what I'm going to recommend. So that we're all doing the same thing. You have lots of options. What I want you to do is convert each of these to just plain old meters. Okay, convert each of those 3. And so I've saved you a little work. The first one is already meters. You don't have to do anything to it. So convert all of them to meters and then place them from smallest to largest. Okay, so the 3.4 is already in meters. That's why I picked it, because it's already part of this, so I don't have to do anything with that one. The 3,421 millimeters. To convert milli to meters, if you went to your prefixes, you saw that you have to make 3 hops to the left. So 1, 2, 3. So that is 3.421 meters. And then to convert 104 centimeters to meters, when you go back to your chart, you're gonna hop 2 to the left. So 1, 2, that's 1.04 meters. So the original question was, let's write these from smallest to largest. So that means which one of the original 3 was the smallest measurement? Yep, the 104 centimeters was the smallest. Which one comes next? 3.4 meters. And then the last one is going to be the 3,421 millimeters. So the exercise is just doing your conversions so that you can accurately compare the 3 things. So do the same thing in exercise 4. Again, so that we're all doing the same thing, convert to meters again. You don't have to if you don't want to. You can convert to anything. Our answers will end up being the same. So converting hecto to meters, that you're going to move the decimal 2 places to the right. So that means I've got to add 2 zeros. So that's going to be 51,400 meters. Converting kilometers to meters, I got to move the decimal 3 places to the right. So that's going to be 62,000 when I add my 3 zeros on. And then I've got 680 meters. I don't have to do anything to that because it's already the basic unit. And so going from smallest to largest now, so now they're all in the same unit. I can now accurately compare them. The 680 meters is the smallest one. The 514 hectometers is the next one. And then the 62 kilometers is actually the largest of those 3 distances. All right, last one. Convert those, it doesn't really matter, convert those to liters, and we'll see how it goes. All right, so the first one, the 4.3 is already liters, nothing to do there. The second one is 420 centiliters. So to convert centi to liters, I move 2 to the left. So 1, 2. So that's 4.20 liters. And then the 0.045 kiloliters, to turn kiloliters into liters, I move 3 decimals to the right. So that's 1, 2, 3. That's 45 liters. So going from smallest to largest, which was the assignment for us, the 420 centiliters is the first one. That's the smallest. The 4.3 liters is next. And then finally, the 0.045 kiloliters, that even though it's the smallest number, it is actually the largest measurement because of the units that are used. One more thing we're going to talk about. If there's a question, feel free. We're going kind of leisurely here. From section 7.2, when you go to do your homework, there's only one thing we're going to talk about, and there is a relationship between my measures. When I find volume, we're going to talk a little bit more in the next unit, not unit C, but unit D, about finding volumes of figures. But when you find the volume of something by multiplying the length times the width times the height, you can then convert that into liters. So for instance, the only thing in this class right now, at this point in your lives, that I assume you know how to find the volume of is a box. Okay. So the volume of the box. So a box is just something that looks like this. You can see my amazing artistry right here. You can remember perspective from 5th grade. And so the dimensions of a box, we've got our length, L, we've got our width, W, we've got our height, H. Does anyone remember how you find the volume of a box? How do you find how much can fit in there? Anybody remember that? Yeah, so if you don't know the volume of a box, well, here it is. To find the volume of the box, it's just the length times the width times the height. Okay, that's it. You just multiply the 3 dimensions together. That is all. So circle that. You're going to need that on your homework. You'll need that on the test, because this is my favorite problem in these first 2 sections. So I definitely put one of these on the test. So just keep that in mind. The relationship between our liters and our length times width times height goes like this. 1 centimeter cubed. Okay, so if I have one little centimeter, so it's like a box box, I don't even know what we would compare it to, but it's just a tiny little box. A centimeter cubed is equal to a milliliter. And as I mentioned earlier, a can of Coke is 355 milliliters. Okay, so that's gives you kind of an appreciation for how small a milliliter is, because there's 350 or 355 of those in a can. A decimeter is equal to a liter. So if you think about a 2-liter bottle of Coke, okay, the volume of that, if you take half of a 2-liter bottle, that is a decimeter cubed. And then 1 cubic meter. So if I have a big box that is a full meter stick, high and wide and long, that is 1,000 liters. It's 1 kiloliter. So it's just a 1-to-1 conversion right here. So we're going to practice using that. Here's my example. We got a swimming pool. Our swimming pool is 18 meters long, it's 9 meters wide, and it just has a uniform depth, to keep this problem nice and straightforward, of 3 meters. So it's just a big box filled with water. So what we're going to do first is we're going to find the volume of the pool in cubic meters. Okay, well, we can do that. The volume of this pool is going to be 18 meters times 9 meters times 3 meters. We're just going to multiply these 3 things together. All right, well, I can't do that in my head. So it's going to be like this: 18 times 9 times 3. You use your calculator, that gives you 486. And since each dimension is a meter by meter by meter, I'm going to write it like this: meters cubed. But if you prefer, if you don't like exponents, you could write it as cubic meters. Doesn't matter which way. Okay, so step 1, you find the volume of the box. It's just the length times the width times the height in every one of these problems. Okay, all these problems are the same thing. The second part of the problem says, okay, take that volume that we just found in cubic meters and convert it using the table up top into something related to liters. Okay, so according to my chart, if I have cubic meters, what is that the same thing as having? Here's my cubic meters right here. When I look across, what's cubic meters the same thing? Yep, a kiloliter. Perfect. So meters cubed and kiloliters are the same thing. So instead of 486 meters cubed, I can just say this is 486 kiloliters. 6, yes, I reversed it. Good job, Perkster. We'll try it again over here. Much better. That's just my self-talk right there. Yes. I'm so old that that used to be my nickname in college. So since I'm in college right now with you, I'm still calling myself that. What's that? Jit? Did I probably just said something. I don't know what I'm saying. I'm gonna have to erase this. So I'm gonna stop talking right now. Okay, so now the last thing then, I've used the table, I've converted between my cubic meters and my kiloliters. The last question now refers back to our prefixes. Now, how many liters can that pool hold? So if you go back, if you flip the page, or if you rewrite your prefixes to convert from kilo back to plain old liters, you move 3 decimal places to the right. So I have to add 3 zeros onto this, so it becomes 486,000 liters. And there we go, done. So I'm going to leave that there so you can see it. I would like you to please work through exercise 6. It's the same 3 questions for you to practice. All right, so the volume of the box, I just cut and pasted and forgot to change the word. So we've got our box, it's 15 centimeters long, 12 centimeters wide, it's 20 centimeters tall. So the volume is just the length times the width times the height. So 15 times 12 times 20. And what do we get in our calculators when we multiply those things together? 3,600? Thank you. So that's 3,600 cubic centimeters. I'm just going to write that centimeters with a little exponent of 3. So then the volume in the liters related unit. So I've got centimeters cubed. So I come up to my chart. Here's my chart right here. Centimeters cubed is milliliters. So that becomes 3,600 milliliters. And now, again, convert that to liters. When I go to my prefixes to convert between milli and my base unit liters, I move the decimal 3 to the left. So when I do that, 1, 2, 3, that is 3.6 liters. All right, one more just to practice, then we're done with section 7.1 and 7.2. Yes? Uh-oh, what'd you do? So you said that this was up here when you found the volume, you got killed. Oh, okay. Yeah, so just have to, you probably did kiloliters because that's what we had in the previous problem. Just got to pay attention to the units for the problem. So this one says that the dimensions of the box were in centimeters. So that's what tells me that it's going to be in cubic centimeters. Okay. This one up here, it was in meters. So that's where we got meters cubed. The next one that we do is going to be decimeters. So pay attention to that. So then when you make the conversion using the table, we notice we've got centimeters cubed And so that's why I used this line of the table to go from centimeters cubed to milliliters instead of going to kiloliters. Okay, we're just going straight across to determine which one's equal to the other. So in the previous problem, we were in meters cubed, and that's why we used kiloliters on that one. All right, so try exercise 7, one more try. If you did good, do it good again. If you made a mistake, learn from the mistake. Okay, so the volume of the box is 12 decimeters times 8 decimeters times 5 decimeters. If I'm doing my multiplication right, is that 480? 480 decimeters cubed. So I'm going to go and use my chart again. Decimeters cubed is on my chart. It's right here in the middle. So decimeters cubed is the same thing as plain old liters. And so that becomes 480 liters. And then this is where I get in trouble for just copying and pasting. So then I've done the B part, the volume in the liters related unit is 480 liters. How many liters? Well, we just did that, so it's not really a very good question. I should have proofread, sorry. So we end up with 480. So if I asked that question on the test, I would probably change this to something like how many centiliters or milliliters or something like that, so that the purpose of the C part is to have to use the prefixes and to make that conversion. So